before getting into wavelength a little bit more on frequency. So we looked in the last video there, both of my red dot and the animation here, that it's pretty easy to achieve a frequency maybe of like 1 hertz or 2 hertz, something like that. That's how many times something can go sort of up and down, like this kind of, here's 1 hertz, something like that. But what about faster frequencies? Is it possible to go up to 10 hertz, 10 times per second? How about 100 hertz? Or how about even 1,000 hertz? Or what prevents us from stopping there? How about like 100,000 hertz? Like, is it possible to make something go up and down 100,000 times per second? Turns out it is. And you can bet when you're dealing with light, which is our underlying topic right here, things get pretty fast. So the way I like to illustrate frequency too in another way is I hope you get the basically the up and down sort of rate is the best way to think of frequency, okay? But it turns out sound is a good way of illustrating frequency as well, because sound is definitely tied to frequency. And so what happens with sound is that you get a speaker like this, which is an electronic device that sort of plugs into stereos, and these are miniaturized things in your ear pods and all those sort of things. But they always have something in the speaker called a cone. And what this cone can do, this little thing in here, is this cone, it turns out, can move in and out. So it can go this way, and it can go that way, and it can do that. And so I hope you're getting the point here. I just said in and out just because of the way I've drawn this cone here, but in and out is a lot like up and down. So it doesn't always have to be vertical. It doesn't have to go up and down. You can go sort of out and in, or right and left, right? And so what happens is if you can get this little cone to vibrate back and forth, then what is all surrounding the speaker? Of course, now I know I've used these white dots a lot in this class for stars, but in this case here, let's say they're air molecules. So what'll happen is this plunger or this speaker will push on these air molecules around here. And what'll happen is, if you can imagine this thing coming out and pushing on the air here, giving this air a good push here, what the air will do momentarily is kind of bunch up on itself like that where it got pushed. But then the air will relax, but then as this thing relaxes, it'll push on the air next to it, and next to it, and next to it, like this. And so what you'll get are these sort of periodic density shifts in the air. And if you think about it, this sure looks a lot like a wave, like high density, low density, high density, low density, high density, low density, high density, low density. This is just what happens when this cone pushes on the air. Okay, and then what can happen is you can be downstream from this, maybe like right here, with your ear or whatever, and this air density can then be pushed into your ear and allows you to hear. And so what's cool about sound is that our ears are remarkably sensitive to these sounds, and so we can hear sounds that have very high frequencies, some of these numbers that I'm even talking about right here. So what I'm going to do is I'm going to generate some sounds of a certain frequency and let you hear them, and we'll just go from there. So I'm having to sort of orient my microphone towards my computer speaker, but here we go. The first sound I'm going to play you is a sound of 50 hertz. Okay, this will be 50 hertz. So the cone in the speaker is going to push the air at 50 times per second back and forth. There's 50 times per second. Okay, here's 100 times per second. So the speaker in my computer is going back and forth 100 times per second. And here's 200. Here's 200 times a second. See, we start to get these tones going on there. But again, this is the speaker in my computer pushing the air around it so we can hear it. Here's 300 times per second. See, 300 times per second. There's no way I'm going to make my pen go that fast on the iPad, and there's no way that simulation is going to go that fast, but speakers and sound can do it easily. Here's 500 times per second. A 1,000. $5,000 times per second. And we ask these numbers about how high can we go? Can we go to 10,000 times per second? Yeah, humans can just about hear that. So I don't know if you can hear that or it's coming through on the YouTube video or not, but I heard a very irritating high-pitched screech. I'll try to go one more to 20,000 times per second. So you might be able to hear that, but I could not. And I don't know if it's going to come through on the YouTube video or my microphone's able to pick that up. But those are an example of frequencies that sound is able to generate. So it's just another example of that. So we'll move on into light now, and I'll tell you about how the frequency and the wavelength and all that come together for light.